Hello all, hope you all doing good. This is Mani and I'm back with another video. In the last couple of years, if you're in the field of IT or software engineering, you might have heard a lot of buzz around the field of data engineering. Every company wanted data engineers, and needless to say, the demand for data engineering roles was sky high. Before we understand why this was the case, we should understand what the hell is data engineering and why do we need it. Also, we should ask ourselves and explore the important question of the hour, that is this just another field that is gaining a lot of buzz and will vanish the other day? So we have a video ahead of us to answer all of these questions. So without further ado, let's get started. Before we jump on to exploring what is data engineering, we have to understand where does data engineering fit into a company. Suppose a data analytics team within a company is tasked to generate few reports for the business teams. These reports will help the business teams to make strategic decisions. These are very important for them and they need it periodically within a schedule. So the data that is required for these particular reports is with different teams within the same company. Like, for example, let's say a finance team which has an SAP system, and then the sales team with an SAP system, and a marketing team which has Salesforce CRM as their tools. So the data will be captured in those tools for their teams. Now, since the data analytics team want to access this data to generate few reports, they have to get in touch with the data owners or the product owners for that particular team and start uh, getting in the data and storing it in a particular system, right? So based on the sensitivity of the data, this can prove to be a hassle. And if everything goes fine, the data will be with the data analytics team, within few weeks. Not all the data that is present in those systems will be given to the particular data analytics team. Only the subset of the fields or even few tables within that system that the data analytics team really needs will be given to them. So once the data is acquired from all of the teams, the data analytics team cannot just go on building the dashboards or reports, right? This is because the data in those systems is not standardized. The same thing in one system can mean different things in another system or have completely different meaning altogether. So this is a problem because let's say, for example, the finance team has data in dollars and the sales team has the data in rupees. This is not the same data. We cannot use the data as is. So there needs to be some effort that needs to be made to convert the data that is present in one format or different formats in this matter into one single format at the end. So there is a lot of engineering effort that needs to be carried out to bring the data from all of these systems, store it in one place, and clean, standardize, transform the data into one agreeable format, and then later use that particular data to generate the reports. This, as we have said, is a lot of engineering task that the data analytics team is not interested in taking up. And since they are dealing with multiple stakeholders, few things could go wrong and they have to start all over again. Maybe it the understanding of the data, maybe it is a few nuances about how the data is being recorded. All of these things need to be understood from each different teams, right? Let's say all of this is successfully completed by the data analytics team. Now a report is generated. Once the report is passed on to the stakeholders, the data that supports or the data that is used to generate this particular report will be under constant scrutiny, because they have to check whether the report shows the numbers as accurately as possible, uh, and how did they end up with certain numbers. So all of these questions will arise from the stakeholders. These are really genuine questions. Let's say these are reports for monthly sales, or how much we have spent on user to acquire, so on and so forth. So this is proven to be a lot more engineering task than data analytics task, and this could also mean that the data analytics team will have to undertake the efforts periodically to generate one single report, and there is a good chance that the requirements would change, and then the parameters would change, and the data analytics team might have to sometimes start all over again, or even modify heavily on the existing report steps that they have taken. The goal of any analytics team is to use the data that they are supposed to use and generate reports or dashboards that they are assigned to. They are happy to skip any engineering tasks that are being done in this particular example. So neither the product teams nor the data analytics team in this particular scenario want to uh, perform that engineering effort to get the data into one single format, because they have their own goals to pursue. There should be an interface between these two systems to pass the data from all of the source systems to consuming systems like BI dashboards, or any data analytics work. So who does that, and how do they ensure the data quality? This hole will be filled by data engineering team. And now, if we check formal definition of data engineering, it deals mostly with bringing in data from different sources, uh, cleaning it, storing it, processing it, and serving the data to different stakeholders, whoever wants the data. We'll explore about this in the next section of the video. Now, in the last example, we have understood the need for data engineering. Now, let's formally define what data engineering is. Simply put, data engineering deals with collecting large amounts of data from different source systems that generate the data, store the data, process it, and then push the data to different stakeholders that are expecting the data. The data can be from any different source system, ranging from a database, an API, or file system, a streaming data, and so on and so forth. Now, once the data is in the collected, it is stored in a large scale analytical or archival storage system called a data warehouse. We will discuss about why do we need a data warehouse a bit. What data engineering does actually is, the once the data is acquired, the data will be analyzed afterwards. Once we acquire a sample of the data, uh, there will be a process is set up to uh, clean the data, to transform it into the required uh, format that is requested from the stakeholders. To make all of this possible, data engineers will build pipelines and employ processes like ETL or ELT. I have explained these concepts in a separate video. I'll link that video in the below description below. Please check that out to understand how we are bringing in the data and how it is processed on a very high level. The end goal of any data engineering activity is to provide data for any stakeholders with the right access to access any data that is generated within a company. And this data that is provided to that particular stakeholder will be standardized, meaning the data that is present in a particular data warehouse table will mean the same thing through across. It doesn't change uh, between any stakeholders accessing that particular data. So why do we need a data warehouse? So in the last example that we discussed, we just took an example of one single team that is trying to acquire um, small amount of data from different stakeholders, right? So building a data warehouse or a data platform will enable us to provide data for any teams that is trying to access the data, right? What does this mean? Let's say a machine learning team is hired to build predictive models on uh, our data that is present in different systems. They don't have to build their own process of acquiring and processing the data, because that would lead to more confusions, and it will start a whole another debate about whose data is better. So we might want to avoid any form of confusions or any form of debates on uh, which data is correct, right? So data warehouse or data analytical system solves this problem very fairly straightforward. Data warehouse solves this problem fairly straightforward. With having one single source of truth for any of the stakeholders, it will provide the data as and when they require. Also, there is no duplication of effort for any team to acquire any data. So, this is one good example on why we want a data platform or data engineering activity in the first place. Now, since we understood about what is data engineering and what all it does on a very high level, we will answer the most important question in the video. Is data engineering a new trend? Will it going to be gone for good after few years? And what about the future of data engineering, right? These are like same question with different flavors, but I'll try to answer with uh, for the first part of the question, like, is data engineering a completely new trend? No, it's not. Data engineering is always there, but called with different names and different roles in different times in the past few years. Like software engineering, data field altogether had few major transformations. In the very early days of computing, most of the analytics ready data was in some form of a relational table in a database, and then that's it. So a data warehouse engineer or a data warehouse specialist used to acquire the data from these databases and store in large scale machines called data warehouses, where they used to store the data for archival purpose or any large scale analytics. These were very huge systems with lot of data in them. As the transformations happened, the internet happened, we see new roles emerge or new technologies emerge, like say Hadoop, which was one of the major driver of something called as big data. So when the Hadoop came into picture, we saw uh, multi-node cluster environments where the data is stored on these clusters and the processing happens locally on those clusters, right? And we had Hadoop engineers, Hadoop admins who manage those clusters, and so on and so forth. So then Spark came into picture, and then uh, we had Spark engineers. Uh, Later, the cloud happened. So we see a lot of clouds. When the clouds appeared, all of the roles that were doing either the data warehousing, ETL roles, or uh, Hadoop engineers, all of the roles somehow got consolidated into one single role called data engineering. So data engineering is not a new trend nor a new role. It has gotten this name fairly recently compared to other roles that were part of this same work because of the transformations happened in the industry. To finally answer the question, is data engineering going to go away? No, because every team, as we have explored in the earlier example, needs clean data to do the analytics, right? Maybe to improvise their product or improvise the services to the customers, or serve the customers better. Anything that has to do with uh, improvising the business will come from data to start with. So everybody wants clean data, but nobody wants to make the effort for getting the data into the right place, and serving the data at scale. So this is where data engineering comes into picture. Even though it is internal to the company, it provides enormous amounts of value and decreases frustration among any analytics teams. So yeah, no, no. Again, I'm iterating again. Data engineering will not just vanish away after a few years. It might take a new name, like it did in a few transformations earlier, but yeah, it doesn't just go away. Also, there is an interesting video that I will link in the description. This video is from a Seattle data guy who explained about the clean data in a company. It's a very interesting video, and every data engineer should check it. At this point, we understood what is data engineering and the importance of it, and answered ourselves few important questions. Now we'll also understand what are the roles and responsibilities of the data engineering team or data engineers in general. And also, last but not least, we'll understand about the challenges of being a data engineer. Let's start with the responsibilities of a data engineering. A data engineering team is responsible for identifying the data, different data sources that is across different company. Let's say we are in a large scale enterprise, we might have different teams doing a lot of activity on their particular uh, systems. They have their own processes, all of that. That data needs to be available in for any other team that has access to that particular data, and continuously, because it will unlock further potential for the businesses to improve, or even start new services or products to improve upon. Now that is one of the biggest requirements for a data engineering team. Once we identify these sources, we start to analyze the data uh, by bringing in some sample data, and then we start building out pipelines to ingest the data. These pipelines again run on a schedule and uses ETL process. We define how we are bringing in the data, where it is, where it should be stored, and then how it is processed. The business teams or any stakeholders that wants the data after the data engineering effort is done, maybe from the data warehouse, will define what kind of transformation logic or business logic to be applied. We cannot just route the data coming in as is to the stakeholders, right? There can be few issues with the data, maybe duplication of the data, or some records that the stakeholders are not expecting. So we need to build the processes such that these records are being filtered out, or only the records that are needed will be given to the end users. Also, we need to make the data pipelines resilient. Let's say the job that runs these pipelines failed for some reason. We have to be able to restart the process and continue from that particular point. Apart from that, data engineers or data engineering teams will also be participating in creating specialized data sets for a machine learning team, a BI team, or visualization team, or external stakeholders, anyone who wants the data. So these are not the data that is just acquired from different sources. These are very specialized, meaning maybe some aggregates data, some processing that had to be done on scale before it is ingested into a machine learning algorithm. So all of these will be part of our data engineering processes. Last but not least, we also should maintain our data infrastructure and make it scalable. Today, we might get a terabyte of data in a month. Let's say the business is booming and we get 10 to 20 terabytes in one single month. So we have to scale our data infrastructure as per the data needs. So this requires proper planning and without any downtime, right? All of these tasks are belonging to a data engineering team. Now let's talk about few challenges in data engineering field. The whole data engineering effort that is done is internal to the company. What does this mean? A sales team is responsible for bringing in customers, interacting with customers, and generating revenue, right? So they interact with customers and bring in business, right? A marketing team, goes to clients, customers, and they will bring value to the company, right? So a data engineering team might not be in a position to interact with any customers directly. So any stakeholder that we are interacting with on a day-to-day basis for the most part would be the internal teams within a company. So having a data infrastructure is needed and understood by many of the teams and business leaders at this point, but it is very hard to justify the efforts that goes into maintaining these data infrastructure or data pipelines will not be recognized as much as any other teams that are directly facing with the clients or customers. So this is what an internal to the company means. Last time when I checked, the machine learning team or deep learning or AI, all of these fields got a lot of boom, and then they fell short for most of the expectations because the data that they required was not in the format, and then they started doing their own data pipelines, how the data is processed, and it was not efficient. Since the data engineering came into the light in last couple of years, this increased the probability of having the success more, when compared to uh, teams working in silos. Now we also discussed about creating specialized data sets in our data warehouse for any specialized purposes for machine learning or BI. So these can go out of hand because data engineers have to maintain their pipelines. That is their first priority, and again, have to make changes on their own pipelines when some changes happen at the applications level from the sources, and they have to integrate those changes before they receive the data itself in our data warehouse. Because unlike databases, data warehouse are different, and if the data is just ingested without any notice, they can break down. When creating the specialized data sets, it requires a lot of time and effort and coordination between different stakeholders. And when a team can outsource the data tasks, they will do it to a data engineering team because data engineering team is one of the closest that deals with all the data from an entire organization. This might prove a little bit hectic for the data engineering team to always keep up with maintaining the data infrastructure, maintaining the uh, data pipelines, and again, taking the request that is coming in from the different stakeholders. Also, the more paramount importance for a data engineering team is maintaining the data quality. When the quality is out of hand, nobody cares about anything else. So that is there. So this could prove to be a challenge and one of the most concerning one as well. Also, there is a lot of context switching. Context switching here in this case meaning, suppose we start to build a pipeline and we have done with the pipeline. So when the pipeline is in operation, we start to build, take up other activities. But if something, goes wrong with the pipeline, we have to go and firefight that particular uh, issue. When it is done, we have to again come back. So this happens quite a lot because a data engineering team can handle anywhere between, tens, if not hundreds of pipelines at a single team. Not not only single member handles or handful of people handles it. There will be large teams that handle data engineering efforts, but even then, context switching is one of those things that kind of kills the productivity, and errors creep up over the time within the data. So this is not a very good look on how we are handling the processes, right? There is a interesting article uh, by Maxime. He's creator of Apache Airflow, on context switching and how it can affect negatively on data engineering activities. I'll share the link in the description below. Please check that out as well. So this concludes the video. Hope you liked it and hope you feel this is informative. Let's meet on the next video where we will discuss elaborately on the skills that are required for a data engineer. I'll share the details on how I went through the journey and any tips and tricks that might help you for the long run in this particular role. So let's meet in the next video. Bye bye.